Assalamualaikum and hello everyone. Today I'm going to explain regarding our smart indoor comfort monitoring system using Arduino Uno. Before we dive into the project, let me introduce our team member. I'm Yasmin Zahira binti Muhammad Amin, and with me I have the other 4 members, which are Muhammad Izlan Rafiq bin Muhammad Ali, Muhammad Akmal bin Muhammad Rezwan Go, Ruhayah binti Salim, and Syahmi Aiman bin Syahir Azhan. Together, we work on developing the smart indoor comfort monitoring system. This project is actually designed to help maintain a comfortable indoor environment by continuously monitoring key factors like temperature, light intensity, and humidity. Using sensors connected to an Arduino Uno, the system not only displays real-time data on an LCD screen, but also control devices such as fan and lighting based on the sensor reading. Now, let's take a closer look at 2 main sensors in the system that I'm in charge of, the soil moisture sensor and the temperature sensor. Starting with the soil moisture sensor. Soil moisture sensor is the replacement to our humidity sensor. This sensor measures the moisture level in the soil and output the analog value ranging from 0 to 1023. A lower value means dry soil, while a higher value means wet soil. In our system, we use 2 threshold values to determine the soil condition. If the sensor reading is below 300, the soil is considered dry and the dry soil LED will light up. If the reading is above 700, the soil is considered wet and lighting up the wet soil LED. Values between 300 and 700 indicate moderate moisture, which turn on the middle LED. Now, let me show you. So, here is our soil moisture sensor, and as you can see, when the sensor reading is below 300, is below 300, the soil is considered dry. And here, our red LED bulb is light up. But when I adjust it to the maximum reading value, the soil is considered wet. So, it's lighting up the wet soil LED, which is the green bulb. But when the value between 300 and 700 is monitored, it will turn on the middle LED, which is the yellow LED, as you can see right here. Now, moving on to the temperature sensor. It's actually provide a voltage that we convert into degrees Celsius. The system then compare this temperature with preset limit. Temperature below 20 degrees Celsius are labeled as cool, turning on the cool temperature LED but keeping the fan off, while temperature above 28 degrees Celsius are considered hot and will activating the hot temperature LED and switching the fan on to cool the room. Temperature between 20 and 28 degrees are moderate, turning on the mid temperature LED and will keeping the fan off. Now, let me show you. So here is our temperature sensor. When I put the temperature above 28 degrees Celsius, as you can see, it's considered hot and activating the hot temperature LED, which is the red bulb, and also switching the fan on to cool the room. But when I keep the temperature between 20 and 28, it will turn on the mid temperature LED, which is the yellow bulb, and keeping the fan off, as you can see right here. But when I change it to the lowest temperature, you can see that it's labeled as cool and turning on the cool temperature LED and keeping the fan off also. By continuously monitoring the sensor value and applying this threshold, the system helps maintain indoor comfort by giving clear visual feedback and controlling environmental devices. Now, I will pass the floor to my next friend.
This section covers the light intensity sensor integration in the smart indoor comfort monitoring system. The purpose of this module is to detect surrounding brightness levels and automatically control the indoor lamp for optimal lighting conditions. The sensor used is a photoresistor, or known as LDR, connected to analog pin A0 on the Arduino Uno. It works by changing resistance according to the amount of light it receives. In bright conditions, the resistance becomes low, and in dark conditions, the resistance becomes high. The Arduino reads this change as an analog value from 0 to 1023. These readings allow the system to determine if the environment is bright or dark in real time. The lamp is connected to digital pin 7 and is controlled automatically by the Arduino. When the LDR detects low light, the lamp switches on. When the LDR detects high light levels, the lamp switches off. This function ensures that the lamp only operates when necessary, providing proper lighting while avoiding unnecessary energy use. This module is also linked with the manual override feature. In normal mode, the lamp follows the sensor reading. In manual mode, the lamp stays on regardless of light conditions, giving flexibility to the user. By integrating the light intensity sensor, the system can automatically adjust lighting, maintain comfort, and of course, operate efficiently as part of the complete smart indoor comfort monitoring system.
My name is Rahaya and I am in charge of actuator control. In other words, how our system responds to changes in temperature and humidity. First, I will demonstrate the temperature. If we set our temperature to below 20 degrees Celsius, the yellow LED will light up. This indicates that our environment is cold. And if we increase the temperature to above 20 degrees Celsius, the green LED will light up, indicating that our environment is at a comfortable temperature. And if we increase the temperature furthermore, the red LED will light up, as well as the DC motor will be activated. This acts as our cooling fan. Now I will demonstrate the humidity. Right now, our humidity is low, and as we can see, the red LED light has turned on. This indicates that our environment is dry and low in humidity. And if we further increase the humidity level, the yellow LED light will light up. This tells us that our environment is moderately humid. And further increasing the humidity, the green LED will light up, indicating that our environment is very humid. Now I will pass on to Shahmi to demonstrate the manual override and safety features.
Hello, my name is Shami Ayman and I would like to talk about manual override and error display. Our system is designed to run automatically, but it also includes two important user control and safety features, which is manual override and error display. First, the manual override controls the lamp. Normally in auto mode, the lamp brightness follows the light sensor, which is this. Dim in bright condition and bright in darkness. The override button is connected to pin D4 using the Arduino input pull-up setting. This means the button is active low, it reads high when untouched and low when pressed, so no external resistor is needed. Here the manual comes in. To make the button reliable, we use a debounce with delay of 50 milliseconds. This filters out the noise from mechanical button press. Every valid press toggles a boolean variable called manual mode. In auto mode, lamp brightness is based on sensor reading. Manual mode, lamp is forced on at full brightness using analog right lamp pin 255. This is useful for testing emergencies or when the light sensor is not working correctly. By default, the system starts in auto mode for safety. The second feature is the error display. You can see it, error here. Our code constantly checks all three sensors: temperature, light, and soil moisture. For invalid readings, if any sensor returns 0 or 1023, which is very high, or the temperature reading is unrealistic, it triggers an error. When an error is detected, the error LED on pin 6 blinks every half second. The LCD shows error, so the user knows a sensor has failed. This is important because it prevents silent failure. Even with a sensor fault, the manual override still working, allowing the lamp to be used until repairs are made.
Hello, my name is Isla Rafiq and I am responsible for monitoring system and a real-time display. Monitoring system is very important because it can give you a real-time awareness. As continuous monitoring provides up-to-date information on environmental conditions such as temperature, light intensity, and humidity. This real-time data allows the system or user to respond immediately when any parameters deviates from the optimal range, ensuring that the indoor environment is comfortable for people to live in. The output display serves as a vital tool for checking the accuracy and reliability of sensor readings. By presenting the live data, it allows users to quickly identify any irregular value that may indicate sensor fault, wiring error, or calibration issues, making troubleshooting more efficient and reducing downtime. So here is some example. The LCD shows T, which is for temperature, L light intensity, and H humidity. So if I were to change the humidity a little bit lower, it will change its value. And if it's past the limit, and it will be a danger if the humidity is too low, it will shows ERR, which stands for error, and it will warn the user to increase the humidity. Same goes for the temperature. If temperature is too high, it will shows the error. And lastly, the light intensity. If we bring it up, and it will shows the light intensity will increase. And also, if you push this button a few seconds, it will show M, which is the user are in manual override. And if the screen does not shows anything, it means the system is in automatic. That's all.